Regula-Falsi method. This is the oldest method of finding the real root of an equation f of x equals 0. Here we choose 2 points a and b such that f of a and f of b are of opposite in signs. That is, f of x should satisfy intermediate value property. So already in the previous video we have discussed about intermediate value property. You can see that video. So if f of x has opposite in signs, so it indicates that a root lies in between a and b, and the formula to find the root is given by x equals a into f of b minus b into f of a by f of b minus f of a. So this is the formula to find the real root in Regula-Falsi method. So now let us solve a problem on this method. Use Regula-Falsi method to find a root of the equation x cube minus 5x minus 7 equals 0. So given function, take the given equation as f of x. So f of x is equal to x cube minus 5x minus 7 equals 0. So first we have to locate where the root lies. We have to find the position of the root where it lies. So by inspection method we have to give values for x, like x equals 0, 1, 2, 3, etc. So first time give x equals 0, f of 0 is 0 minus 7, so which is equal to minus 7 less than 0. Then put x equals 1, so f of 1 is 1 minus 5 into 1 minus 7, which is equal to minus 11 less than 0. Then put x equals 2, f of 2 equals 2 cube minus 5 into 2 minus 7, that is minus 9 less than 0. Then put x equals 3, f of 3 is 3 cube minus 5 into 3 minus 7, that is plus 5 greater than 0. So for x equals 2, f of 2 is minus 9 less than 0. For x equals 3, f of 3 is plus 5 greater than 0. So for one value, for x equals 2, it is less than 0, functional value is less than 0. For x equals 3, functional value is greater than 0. So by intermediate value property, so f of x, so the function f of x satisfies intermediate value property for x equals 2 and x equals 3. So that is one value is less than 0, another value is greater than 0. So root lies in between 2 and 3. So now again we have to move closer to the root. So we got that root lies in between 2 and 3. Now we have to move more closer to the root. So again increase. So again you have to give values for x in the difference of 0.1. So again in the function f of x we have to give values for x in the difference of 0.1. So for example, see the root lies in between 2 and 3. So f of 2 is minus 9 less than 0. Now go on increasing the values of x by 0.1. So f of 2.1 is, by you have to use the calci, it is minus 8.239 less than 0. Again f of 2 is less than 0, again f of 2.1 less than 0. So intermediate value property is not satisfied here. So again put x equals 2.2. So f of 2.2 is minus 7.352 less than 0. So f of 2.1 less than 0, f of 2.2 less than 0. Again intermediate value property is not satisfied. Put x equals 2.3. So this is minus 6.333 less than 0. Again this is less than 0, this is less than 0. Intermediate value property is not satisfied. Then put x equals 2.4. So it is minus 5.176 less than 0. So this value is less than 0. Again here it is less than 0. So intermediate value property is not satisfied. Again put x equals 2.5. So x equals 2.5 is minus 3.875 less than 0. So f of 2.4 it is less than 0. For f of 2.5 less than 0, again put x equals 2.6. So that is minus 2.424. Again this functional value is also less than 0. So for 2.5 less than 0, for 2.6 less than 0, again put x equals 2.7. So f of 2.7 is minus 0.817 less than 0. So for f of 2.6 functional value is less than 0. For f of 2.7 functional value is less than 0, put x equals 2.8. So we get 0.952. So it is plus 0.952 greater than 0. So f of 2.7 we get less than 0, f of 2.8 we get greater than 0. So again intermediate value property is satisfied for f of 2.7 and 2.8. So root lies in between 2.7 and 2.8. So now we have to start the iteration process. So the formula by Regula-Falsi method is x equals a into f of b minus b into f of a by f of b minus f of a. So first iteration, take a equals 2.7 and b equals 2.8. So a equals 2.7, b equals 2.8. F of a is f of 2.7. So f of 2.7 already we have calculated, minus 0.817, minus 0.817. F of b is f of 2.8, that is 0.952. Already we have calculated 0.952. So substitute these values in the formula. So in the first iteration, take x1. So a into f of b. So 2.7 into f of b. F of b is 0.952 minus b into f of a. B is 2.8. 2.8 into f of a. What is f of a? Minus 0.817. So 2.7 into 0.952 minus 2.8 into minus 0.817 divided by f of b minus f of a. F of b is 0.952 minus f of a. F of a is minus 0.817. So minus into minus become plus. So use the calci. So x1 is 2.746. So you have to use the brackets wherever it is necessary. So while typing this equation, use the brackets. So now in first iteration the root is 2.746. So you have to observe that. So root lies in between 2.7 and 2.8, but x1 value is 2.746. So this value 2.746, so it lies in between 2.7 and 2.8. So now we have to improve the accuracy of this root. So again find f of x1. What is f of x1? So it is minus 0.024. Again this value is less than 0. So again this value is less than 0. So now, so the previous value where the root lies before first iteration. So the root lies in between 2.7 and 2.7. The root lies in between 2.7 and 2.8. But the new root, that is x1 value. X1 value we got 2.746. So for 2.7, so what is f of 2.7? F of 2.7 is, it is less than 0. F of 2.7 is less than 0, and f of 2.8 is, so what is f of 2.8? F of 2.8 is greater than 0. So you can see here, so f of 2.7, f of 2.7 is less than 0, f of 2.8 is greater than 0. So f of 2.7 is less than 0, f of 2.8 is greater than 0, but the new root, that is x1, is 2.746. So f of 2.746 is, so f of x1, that is f of 2.746 is also less than 0. So now if you take 2.7 and 2.746, f of 2.7 is also less than 0 and f of 2.746 is also less than 0. So intermediate value property is not satisfied. If you take 2.7 and 2.746, intermediate value property is not satisfied because both the functional values are less than 0. So neglect 2.7. Now take 2.8 and 2.746. F of 2.8 is greater than 0. F of 2.746 is less than 0. So one value is greater than 0, another value is less than 0. So intermediate value property is satisfied. So root lies in between 2.746 and 2.8. So after the first iteration, root lies in between 2.746 and 2.8. So now again we have to improve the accuracy of the root. So again you have to repeat the same procedure. Take A equals 2.746 and B equals 2.8. F of A is f of 2.746. So f of 2.746 is already we have calculated minus 0.024 and f of b is f of 2.8. So this value also we have calculated 0.952. Now substitute these values. So x2 is a into f of b. What is a? 2.746. A into f of b. F of b is 0.952. So a into f of b minus b into f of a. F of a is minus 0.024 whole divided by f of b minus f of a. 0.952 minus of f of b minus f of a minus 0.024. So use the calci. So you have to type carefully. So x2 is 2.747. So f of x2 is f of 2.747. So this value is minus 0.006 less than 0. So again you have to observe that. So x1 in the first iteration we got 2.746 and in the second iteration x2 value is 2.747. Compare these two values. So how many decimal places are same? So 2 decimal places are same. Again we have to improve the accuracy of the root. So to improve the accuracy of the root, so we have to locate where the root lies. So before second iteration, root lies in between 2.746 and 2.8 and new root x2 is 2.747. So f of 2.746 is f of 2.746 is less than 0. F of 2.8 is greater than 0. So f of 2.747 is also less than 0. So if you take 2.746 and 2.747, so f of 2.746 is less than 0, f of 2.747 is less than 0. So intermediate value property fails. So if you take 2.8 and 2.747, f of 2.8 is greater than 0, f of 2.747 is less than 0. So intermediate value property is satisfied for 2.8 and 2.747. Root lies in between 2.8 and 2.747 and 2.8. So root lies in between 2.747 and 2.8. Again in the third iteration, take a equals 2.747, b equals 2.8 and f of a is f of 2.747. So that is minus 0.006 and f of b is f of 2.8. F of 2.8 is 0.952. So now substitute all the values in the formula. So x3 equals, in the third iteration, take the root as x3. So x3 equals a is 2.747 a into f of b. that is 0.952 a into f of b minus b into f of a minus 0.006 divided by f of b minus f of a 0.952 f of b minus f of a minus of f of a is minus 0.006. So simplify using the calci, solve this equation using the calci. So x3 value is 2.747. So in the third iteration the root is 2.747. So compare x2 and x3. So comparing x2 and x3, x2 is 2.747, x3 is 2.747. So after the decimal point all the three decimal places are same, so this is enough. So therefore root is 2.747. So the root of the given equation is 2.747. So after the decimal point at least three decimal places should be same. Let us solve the second problem. Find the approximate value of the real root of the equation x cube minus 3x plus 4 equals 0 using the method of false position. So we have to carry out iterations correct to three decimal places. So correct to three decimal places means after the decimal point the first three decimal places should be same. Now take the given function as f of x, given equation as f of x, that is x cube minus 3x plus 4. Then first we have to locate where the root lies. We have to find the position of the root. So by inspection method give values for x. So first put x equals 0, we get plus 4 which is greater than 0, then put x equals 1, we get plus 2 greater than 0, then put x equals 2, we get 6 greater than 0, then put x equals 3, we get 22 greater than 0, then put x equals 4, we get 56 greater than 0, put x equals 5, we get 114 greater than 0. So if you give positive values for x, so f of x will also be positive, it is increasing. So no use of giving positive values for x, so give negative values for x now. Put x equals minus 1, f of minus 1 is plus 6 greater than 0. Put x equals minus 2, f of minus 2 is plus 2 greater than 0. Put x equals minus 3, f of minus 3 is minus 14 less than 0. So for x equals minus 2, f of minus 2 is 2 greater than 0. For x equals minus 3, for x equals minus 3, f of minus 3 is minus 14 less than 0. So one functional value is greater than 0, another functional value is less than 0. So intermediate value property is satisfied. So by intermediate value property, root lies in between minus 2 and minus 3. So root lies in the interval minus 2 and minus 3. Now we have to move closer to the root in this interval. Again in this interval we have to move closer to the root. Now again give values for x. Starting from minus 2, increase the value of x in 0.1. Start from minus 2, increase the value of x from 0, increase the value of x in 0.1. So f of minus 2 already we have calculated, plus 2 greater than 0. Then f of minus 2, f of minus 2.1, put x equals minus 2.1, f of minus 2.1 is 1.039 which is greater than 0. Then again put x equals minus 2.2, f of minus 2.2 is minus 0.048 which is less than 0. So for one value it is greater than 0, for another value it is less than 0. So here if x is minus 2.1, here x is minus 2.2. When x equals minus 2.1, f of minus 2.1 is greater than 0. When x equals minus 2.2, f of minus 2.2 is minus 0.048 less than 0. So one value is greater than 0, another value is less than 0. So root lies in between minus 2.1 and minus 2.2. So now we start the iteration process. By Regula-Falsi method, the formula is x equals a into f of b minus b into f of a by f of b minus f of a. Now take a equals minus 2.1 and b equals minus 2.2. So when a is minus 2.1, f of a is f of minus 2.1, that is plus 1.039. Already we have calculated here. Then b equals minus 2.2, f of b equals f of minus 2.2, that is minus 0.048, less than 0. So already we have calculated that value also. Now substitute all these values in the formula, in the Regula-Falsi formula. So x1 equals a into f of b. A is minus 2.1 into f of b, minus 0.048, minus b into f of a. B is minus 2.2 into f of a, 1.039. Then f of b minus f of a. F of b is minus 0.048 minus of f of a. F of a is 1.039. So use the calci. We get x1 value is minus 2.196. So now if you observe this value minus 2.196, it lies in between minus 2.19 minus 2.2. So now again we have to improve the accuracy of this root. So find f of x1. So f of x1 is f of minus 2. Again we have to improve the accuracy of this root. F of x1 equals f of minus 2.196. So this is equal to minus 0.002, less than 0. So now for minus 2.1, functional value is greater than 0. For minus 2.2, functional value is less than 0. For x1, its functional value is less than 0. So now, before the first iteration, root lies in between minus 2.19 and minus 2.2. So new root is minus 2.196. So for minus 2.1, functional value is greater than 0 here. So it is greater than 0. And for minus 2.2, f of minus 2.2 is less than 0. For x1, f of x1 is minus 0.002, less than 0. So if you take minus 2.2 and minus 2.196, so functional value is less than 0, less than 0. So intermediate value property fails here. So take minus 2.1 and minus 2.196. So one value is greater than 0, another value is less than 0. So intermediate value property is satisfied for minus 2.19, minus 2.196. So next root lies in between. So next root lies in between minus 2.1 and minus 2.196. So now we have to improve the accuracy of the root. So now in the second iteration, use the value of x1. So now second iteration, so a is minus 2.1. So a value is minus 2.1. So f of a is f of minus 2.1. So already we have calculated f of minus 2.1 is 1.039 greater than 0. Then take b equals minus 2.196. So f of b equals f of minus 2.196. So this is equal to minus 0.002. So now substitute in the formula. In the second iteration, take the root as x2. So a into f of b. A into f of b minus 0.002. A into f of b minus b into f of a, minus b is minus 2.196 minus b into f of a. F of a is 1.039. divided by f of b minus f of a. F of b is minus 0.002 minus f of a is 1.039. So x2 equals minus 2.196. So now compare x1 and x2. So x1 is minus 2.196. So in the second iteration x2 is minus 2.196. So if you compare these two values after the decimal point, all the three decimal places are same, so it is enough. So no need to go further. Therefore the required root is minus 2.196.